Hello everybody. In this video, we would learn how to name unsaturated compounds. And particularly, this video is only focused on alkenes. Now we already know how to go about naming these compounds with a set of prefixes based on the number of carbon atoms. So we have meth, eth, prop, bute and so on, as the number of carbon atoms goes from 1 to 10. Now the only major change that will happen when you name alkenes or alkynes is its suffix. Suffix for alkenes is -ene. Now let's look into the IUPAC nomenclature rules. The rules for naming an alkene follow a similar set as for alkenes, but there are a few exceptions that we need to keep in mind. First one is with regard to the parent chain. This time, the parent chain is chosen such that it contains the carbon-carbon double bond. Now the next thing that we do is number the parent chain, and here the numbering is done so that the double bond gets the highest priority or the least possible number. Then you assign the position numbers to the first carbon in the carbon-carbon double bond. And then we finally write the name and we change the -ene suffix from alkane to that of -ene. Now let's see that in action. For the simplest kind of alkene, which has only one double bond, let us consider some examples and work out their nomenclature. Now this is the first example. In this example, you will see that there are 4 carbon atoms and here you have a carbon-carbon double bond. Now the parent chain is the longest chain possible and this itself contains this double bond. So this is our parent chain and then we can number it this way or this way. Now the second rule to keep in mind is that the double bond gets the lowest possible number. So here we choose the numbering in this general direction. So now to name it, we know it is a bute chain and the suffix is -ene. The only extra thing that we add now to it is the position number for the double bond. And here if you notice that the double bond is between C1 and C2, so we will choose the lowest number, which is C1. So the name becomes bute 1-ene. So it's a butene where the double bond is in the first position. Now you can go ahead and name this compound. This is similar to that as the first compound that we saw, containing only 4 carbon atoms, but the major difference is that the double bond has been shifted. Now let's try numbering this parent chain. So we can go in from either directions this time. It makes no difference since double bond is always between C2 and C3. And now to name this, it's a bute chain. The double bond is in the second position and then the suffix, as we know, is -ene. So now it becomes bute 2-ene. Let's take another example. Now in this case we have a substituent. So the first rule remains the same. We have to identify the parent chain, but the parent chain should contain the double bonds. So this can be the parent chain or this can be the parent chain. I will take the straight chain for my reference. And now to number this, we have to give the priority to the double bond and not to the substituent. So first the priority goes to this carbon atom. So the numbering goes in this general direction. And now to give the namings follow. We write all the substituent names before with their position numbers and then we go around naming the parent. So this here is 3-methyl bute 1-ene. Now here's another example. You can pause the video and try to name this by yourselves. So for this example, this is the parent chain and then we have to number from this direction because the double bond is right here. And then the overall name follows the same patterns. We have ethyl as one substituent and methyl, and we have to write ethyl first because it is alphabetically in the higher order. So we have 4-ethyl 2-methyl hex, second position, so hex 2-ene. Now let's consider another scenario. What if an alkene has more than one double bond? Now, as we were doing it in alkanes, we will use counting prefixes like di, tri, tetra, etc. before ene. For convenience, an A is added before this. This is just done so that it is easier to pronounce this name. So before the counting prefix, we add an A, and I will tell you what this looks like in a second. And then, as we know, when we write counting prefixes, we have to specify the position numbers. So all the position numbers of the double bonds are mentioned, starting from the carbon atom which has the lowest number. Now let's see that in action. So in these cases, the carbon compound will have 2 double bonds. So in this case, we've seen that this is again a bute chain, and there is a double bond this way and here. So now to number this parent gets numbering this way. You can also number it from the other way around, makes no difference. And now you will notice that there are double bonds between C1 and C2. So basically the position number is 1, and C3, C4, so the position number is 3. So now the name becomes buta-1,3-diene. So this is the A that I mentioned before. This is just put in for convenience, since we can say butadiene, and that's easier to pronounce. So, and then you have di as the counting prefix before ene, and all the position numbers that account for those prefixes. Check this example. This is also a bute chain with 2 double bonds, but the name is slightly different because the double bonds are placed in different positions. So if this is the parent chain, now we only have the option of numbering it from this direction, and then the name becomes buta-1,2-diene. Let's consider another example. You can pause the video and count the parent chain and then write the name yourself. So in this example, the highlighted area is your parent chain, and now if you notice, there are 3 substituents, 2 methyl groups and 1 chloro group. So before we consider the substituents, we have to only consider the double bonds. So if we were to number it from this end, it would have been 1, 2, 3, 4, 5 and 6. So the double bonds are at 1, 3 and 5 positions. If we number it from the other way around, again the double bonds are at 1, 3 and 5 positions. So here numbering is not dependent on the double bonds itself because the numbering does not change. So the second thing that you will look into is the substituent, so that the substituent gets the lowest possible number. If we were to number it in this direction, here you would have 2 methyl, then 3 methyl and then 5 chloro. While in this direction, it would have been 2 chloro and then 4 methyl and 5 methyl. So this time the numbering in this direction would give the higher value to the substituents. So we will choose numbering from this direction only. And now to write the names, this one is 5 chloro 2,3 dimethyl hexa 1,3,5 triene. Now what happens if you have cycloalkenes? The same steps follow, that the parent now itself is the cyclic chain. So we add a prefix cyclo to it. Now this time the numbering is important because all the positions in the parent chain are not equivalent. Here the carbons which have double bonds should be given numbers 1. Then we attach all the prefixes for all the substituents with their numbers, and then we come up with the final names like we all know. So let's check out some examples. So in this example, this is a 6-membered ring. It's a hexane ring. But here you have a double bond, so it becomes hexene. And since it is a cyclic compound, it is cyclohexene. Now only difference is numbering is important because the double bond gets the priority in numbering. So we have to number it 1 and 2, and then the lowest number gets the preference. So the overall name becomes cyclohexone. Now let's look at another example. Now this is also a cyclic chain, but the difference is there are 2 double bonds. Now the numbering will start at one end and then continue so that all the double bonds get the least possible number. So assuming I started from this end, we know that the double bonds are at the first position and the third position, and it's cyclobute chain. So the name becomes cyclobuta-1,3-diene. Because there are 2 double bonds, you have a counting prefix di. Since you have the counting prefix, you have the 2 numbers denoting the double bonds, and since it is again having more than 1 double bond, we have an extra letter A. So the entire name is cyclobuta-1,3-diene. Now this one is a cyclopentane ring, and it has 2 double bonds, but it also has a substituent. So let's go on numbering this. So we can start from this end, or we can start from this end and continue in the direction which correlates for the double bond. So assuming I start from this end, so these are the 5 carbon atoms, and the name becomes 5-methyl cyclopenta-1,3-diene. So that's it for alkenes. Now for alkynes, the nomenclature system is identical to that used in alkenes. The only difference being the suffix "ene" is changed to "ine" to indicate a triple bond. Can you name this compound? Kindly write it in the comments below. And that's it for today. Happy learning!